Lesson 8 is the biggie of the first part of electrostatics, charging by friction, induction, and conduction. And hopefully you've been able to watch the demonstration I made, which goes over much of this, because it's difficult for me to demonstrate this on the smartboard. So first, charging by friction. Um, Sometimes by rubbing two things together, you can charge them by friction. So for example, if you rub an ebonite rod, which is hard rubber, on fur, if you rub them on fur, then the ebonite rod will gain electrons, so it will become very negatively charged, and the fur will lose electrons. So electrons are transferred from the fur to the ebonite rod, because remember, we're always talking about the movement of electrons, not protons here. Electrons get transferred from the fur. They both start off neutral to the ebonite, and so overall the ebonite now is negatively charged. The fur is positively charged, but the overall charge of the whole situation is still zero, right? The conservation of charge. So that's one way you can charge an ebonite rod. The other one that we commonly use is a glass rod, and we rub a glass rod on silk. And in that case, the opposite will happen. The silk will become negatively charged. In other words, the silk gains the electrons, and they're transferred from the glass rod, which will become positively charged. Right? So if you rub ebonite on fur and a glass rod on silk, then the glass rod and the ebonite will be attracted to one another, and the silk and the fur will be attracted to one another. The ebonite rod and the silk will repel, and the glass rod and the fur will repel, which is what they go over right here in example 1 and 2. So I've just gone over that. And then we have just some interesting information on specific materials and their tendency to lose or gain electrons. Right, so right at the bottom here, we have glass. Glass loves to lose electrons, and here's the ebonite right there. And you can see ebonite and fur, they have to be in that configuration there, because ebonite wants to gain electrons, fur wants to lose electrons, so they're kind of made for each other. And same with the silk and the glass. The silk is higher on the list, so it wants to gain electrons. The glass wants to lose, so when they rub together, that will sometimes happen. Okay, so that's called charging by friction. Next, we go to charging by conduction. And conduction means touching, charging by contact. When two objects come into contact with one another, then electrons can transfer from one to the other. So that's a key point, that when they're touching, electrons can be transferred from one object to the other. And then when you separate them, then all of a sudden one object has a significantly different charge than it started with. And that's essentially when you're rubbing ebonite on fur, that's essentially what's happening. They're touching. When you move them apart, they both have a different charge, even though the overall charge has not changed. Okay, so now we're just gonna go over these diagrams, and we're gonna see what happens here when we touch two objects together. Here, in this example here, we have a charged object and a neutral object. So this is negatively charged, has a charge of -6. When they touch, what happens? The electrons, so I guess this should be, let's just fill this in. So this is 3 and 3. 1, 2, 3, 1, 2, 3. Right, so it's neutrally charged because it has 3 protons, 3 electrons. And once they touch, once they get close, there is a separation of charge, which we discussed in the earlier lesson. So now all these the electrons, these 3 electrons here, are going to be pushed over to this side here because they're repelled by this. and therefore these two objects are going to be attracted to one another. Now, what happens when they touch? So that's separation of charge. When they actually touch, then objects want to balance themselves out. They want to become as neutral as possible. It's the natural tendency of all objects to be neutral. And therefore, when they touch, it will allow 3 of these electrons to transfer into this one so that both objects balance out and gain as close to a neutral charge as possible. Now, what happens in this case? Since 3 electrons moved over to this one now has the 3 protons, 1, 2, 3, but now it has 6 electrons. It should be 1, 2, 3 there. It has now 6 electrons. Oh, I forgot the proton. Another proton. And the overall charge of the circular object here is therefore -3. And the overall charge of this one is also -3. In other words, they balanced each other out. We did that in this first lesson, the conservation of charge. And therefore, once you separate them, now they will have an overall charge of -3 each. So now these objects will repel one another, which was clearly shown in the demonstration. Right? You hold a negatively charged ebonite rod near a pith ball. They're attracted because of the separation in charge, but once they touch, the electrons in the ebonite are transferred over to the pith ball, and therefore they're both going to have a negative charge, and they're going to repel one another. So that can be a kind of a complicated process, and you should watch the video over or go or watch some other videos online to describe that process of charging by conduction. And the last one, the one that's even more complicated, is charging by induction. And it says it's possible to charge a conductor without coming into direct contact with it. You have to do the following. You have to follow some special procedures. So the key to this, so the key to charging an object without touching it is a grounding wire. What does a grounding wire do? A grounding wire does exactly that. It goes into the ground. And anything that goes into the ground is essentially attached to the earth, and the earth is just one massive ball of charge, and charge can move very freely in and out of the earth. Okay, again, it's neutral for all intents and purposes. There are as many positive charges as negative charges, but because it's such a big mass, electrons move very easily from the ground and into the ground. So here's what we're going to do to charge an object by induction. First of all, we're going to start with a neutral grounded sphere, and this symbol here represents that it's grounded. Then we bring a negatively charged rod next to this sphere, and what's going to happen? Separation of charge. However, because this object is grounded, the electrons, they're all going to go, in blue, they're all going to go over here they're going to be repelled by this section here, so they're all going to go to the opposite side of the sphere. But because it's grounded, the electrons are going to say, what the heck, I've got a path out of here. This is like breaking out of jail. And they're going to go through the grounding wire into the massive reservoir of charge, which is the earth. So in other words, they have an escape, right? They want to get as far away from these electrons as these ones here as possible, and there's an escape route, and they can go into the earth, which is so massive they can get away from these negatively charged particles very easily. Then, now this is the key, so the electrons escape down the wire. So if these electrons actually have escaped down the wire, right, they are no longer part of the system. They're in the earth now. So overall, what's the charge of this object going to be? It's going to be positive. What you have to do now to charge the object without touching it is snip the wire. snip the wire right here. You have to snip the wire and you have to keep this object close so that it's not letting these electrons back into the sphere. So you snip the wire, and once you snip the wire, the electrons cannot get back up into the sphere, because once you remove the object, once this object here is removed, the sphere will naturally want to become neutral again. So it's going to want to accept electrons, and if the wire is still intact here, then the electrons will just come from the Earth. They'll just go right back up into there and say, oh, we're home again and we're happy. So you must snip the wire first. Snip, and then remove the object. And then, so what's happened here? What's happened? The final object has gained a positive charge, even though we held a negatively charged rod next to the sphere. So when you're charging by induction, whatever the charge of this is, the charged object, is going to the object that you're trying to give a charge is going to be the opposite. So this one's negative, therefore this becomes positive. So remember that when you're charging by induction, if you have a negatively charged rod near a sphere, the sphere becomes positively charged. If it's a positively charged rod, the sphere will become negatively charged. Okay, and then there's a video on electroscopes, and electroscopes are just a simple way to demonstrate this process. And how we do for time? I'll just explain it very well. Here's a good diagram right here. So you take a negative charged rod and you hold it next to this electroscope. An electroscope has a metal rod here and a metal ball on the top, and then it has two leaves, usually made out of aluminum or some kind of conductive metal. And when you hold this negative rod here, what's it going to do? It's going to push the electrons from the sphere at the top here down into the leaves, and the leaves will become negatively charged because they're trying to escape. They're trying to get away from this rod right here, and therefore the two leaves will repel one another. Same thing if I hold a positively charged rod next to it, then what's going to happen? The electrons from the leaves will be attracted. They'll actually go up that way. Because once again, I will remind you, we talk about the movement of electrons. We're not going to say that the protons were all repelled down into the leaves. We're going to say that the electrons that were in the leaves move up this way, up because they're attracted to the positive rod, and therefore the overall charge of the leaves will become positive, and again they will be repelled. If you then touch it, in this example here, by conduction, then you're going to transfer excess electrons into the entire structure, and the leaves are still going to repel. So that's how electroscopes work. And with that, there's a video here. This is a photograph I actually took down south of some crazy lightning. And the slow motion video, we'll watch that in class. So there ends lesson 8. It's a really important lesson. It's really important that you understand the concepts of charging by friction, conduction, and induction. So watch this video or other videos multiple times if you have to. All right, we'll see you for lesson 9.